Welcome back, everyone. Our final presentation of the day is one that we've all been looking forward to. Ian Padley is the Global Solutions Team Manager specializing in tissue at BTG. Today he's going to show us how DataPark is used in a tissue application.
Hello and welcome to today's presentation. My name is Ian Padley and I have the privilege of managing the Global Solutions team in BTG Ecripance. We're a business development and applications development team, and as you may judge from the name, BTG is based in the lovely mountain district above Lausanne in Switzerland. So today's topic is our journey from asset protection to continuous quality improvement in the tissue industry. And specifically, we're going to talk a little bit to introduce the tissue industry to some of you who may not be familiar with it from other process industries, and look at one of the big issues facing us, that of craping and asset protection. We're going to discuss how we address the asset protection issue by building a smart vibration monitoring system, which we call Vigilance Pro, powered by DataPark. We're going to take a look at how we leverage the capabilities of DataPark to get into new areas of troubleshooting capability. And we shall close by seeing how the very latest developments are taking us into an Industry 4.0 scenario, a buzzword for everybody at the moment. But let's take a look at the end of this about what BTG and DataPark are doing with our system to move into an Industry 4.0. BTG will be familiar, many people working in the paper industry. Without going through everything on this slide, we're probably best known for our high impact consumables that we produce out of the factory in Switzerland, and innovative measurement technologies, which are produced out of a factory we have in Sweden. A few years ago, BTG acquired Capstone Technologies, and with that, the DataPark organization, well known to all of you here at the DataPark User Conference for its data analytics. What we're really interested about here is the cutting edge model predictive process optimization technologies and the visual data analytics, and that's what we've leveraged in building this new system. So let's move on and take a quick look at the tissue industry. In fact, you will know the tissue industry even if you're working in another process industry here, because you use tissue industry products every day in your everyday life, at work and at home. Some of the typical products are shown here. These will include bathroom tissue, or toilet paper as we'd call it in Europe, facial tissue, hankies, napkins and tableware in the away from home sector as well, and the ever more popular kitchen towel and washroom towel products. The tissue industry includes some truly global companies such as Kimberly-Clark, Georgia-Pacific, Essity, and here in North America, important players such as First Quality Tissue, Irving Paper in Canada, Clearwater Paper, Cascade again in Canada. And a bunch of tissue grades are here that you'll be familiar with. Velvet is a major UK brand where I'm located, and we have a number of very important Georgia-Pacific brands here. I'm sure many of you in the audience will know and use these brands very well. So what is tissue? It's another paper product made of cellulose, which are wood pulp fibers, like any other paper grade, like newsprint or like packaging paper. But tissue undergoes a special process which explodes the sheet to make it a three-dimensional structure and give it the softness and absorbency which tissue consumers need and like. We call this process craping, and it's the heart of the tissue machine and also the heart of an important BTG business. I mentioned the high impact consumables at the start of this presentation, and that's one of the important businesses for BTG, the craping blade. Before we talk about that in detail, let's talk about the basic processes in tissue. We have the stock preparation. We take market pulp, or sometimes pulp from an integrated pulp mill, and it'll be slushed up and made to the correct concentration or consistency to go forward to the tissue machine. What most of us will think of with tissue making is the actual tissue machine, shown here in the middle picture, that makes what is effectively an enormous roll of tissue paper up to 6 meters wide, which is then converted in sometimes on site, sometimes in a separate factory, sometimes in a separate factory on another continent, into the final consumer product. Being at the heart of the process where BTG do our work, is basically a large building size machine, can be up to 6 meters wide, operating at very high speeds, up to 2,200 meters per minute line speed. We form the sheet, spread wet pulp across the width of the web. It's pressed, and it's pressed against a large rotating steam heated pressure vessel, the Yankee dryer, an extremely expensive and fragile piece of capital equipment. BTG is interested in creping the tissue, which happens right here. The tissue paper moves this way around the machine and is creped off at this point, removed from the dryer, and the 3D structure is put in. The 3D structure is created by the crepe blade. It takes a very low weight sheet and adds bulk and stretch. It's a complex interaction between the fiber and Yankee adhesive forces, the doctor blade which doesn't move, and a rotating Yankee which does move. I have a short animation following here which will show just how this works.
The BTG crepe model uses the de-densification concept to explain creping for bulk. We reshape the fiber substrate by exploding it and increasing its thickness during the creping process. The crepe explosion is a function of two opposing forces: the crepe force or adhesive force and the cohesive force of the sheet. The crepe force is applied to the sheet by the coating and crepe action. Balancing this is the cohesive force, which is the internal bond strength of the uncreped sheet.
Having seen how we create the sheet, now we move on to the big issue for which we had to design a new system. The picture you see here is a Yankee dryer with so-called chatter mark damage. This is basically caused by excessive vibration of the crepe blade, which you'll recall is the consumable part which BTG also supplies. And it's caused by a number and interaction of process factors that set this up. Repair of this is very expensive. You may need to regrind or even resurface the Yankee with a thermal metal spray. And the production losses and cost of repair can be many hundreds of thousands of dollars. So the first obvious thing to do is to install some kind of vibration monitoring system. And this is indeed what we're going to look at next. So our journey on this started more than 10 years ago when BTG started using generic vibration monitoring systems based on rotating element monitoring technology, typical for measuring bearings or gearboxes. Many of you will be familiar with this. Effective as a basic troubleshooting tool and very effective as an alarm system. But it needed a skilled user to get the best out of it because the interface was pretty clunky, not operator friendly, multiple root computer menus to navigate to get to the data, no live trending of the data. You had to export data to another system to do effective process troubleshooting. Some of the critical information was only available by clicking onto a certain screen, and that would disable the information stream to another view. You couldn't look at, for example, an FFT and a damage level trend at the same time. So we decided to build a smart vibration monitoring system, and we chose Capstone Technologies as our partner to work with. This was before BTG eventually acquired Capstone Technologies. One of our design briefs was this, the use case. Let's build a Fitbit for a Yankee dryer, a very popular personal fitness monitor. I felt had a really nice dashboard. So we kind of took a few design elements from that. We wanted all the data all the time, an analytical capability, and an ability to cross-reference the data we were getting on vibration with other processed data. DataPark had a great approach to this. They built us a bespoke system to take unprocessed data and put it into DataPark. The engine in DataPark had the deep analytical tools we required and the graphical capabilities to build the live tile user interface that we needed. The pictures here show us a few years ago the Capstone headquarters in Vancouver, Washington, in some of the design meetings we had there, filling the whole wall with post-it notes. I'm sure many of you have done similar things. So let's take a look at the system.
Welcome to Vigilance 4.0. This is the main dashboard that you will see when you start Vigilance. Let's take a look at the key features. On the left-hand side of the screen, we have the Craping Doctor information. Here we have the vibration level monitors. These show the vibration in several different frequency bands corresponding to particular sources of vibration on the machine. Here we have the blade life monitor, which shows the life of the current blade in hours. Here we have the live frequency spectrum from 0 to 20 kHz. Here we have the blade damage indicator, which tracks the vibration increase through the blade life. The current blade is the bright line growing from the bottom, and dimmer lines show the previous two blades for comparison. Underneath, we show the current machine speed, and in the right-hand side of the screen we monitor the cleaning doctor. In this example, the cleaning blade is not in use. Now for a demonstration. Everything looks okay right now, but let's see what has happened in the last 48 hours. To start, I click on the vibration levels. Now I can see the trends for the last 24 hours. Let's look back a little further. Something has caused the vibration to spike. Let's take a closer look. I can use Smart Mouse to see the actual values and timestamps. The vibration has ramped up over 20 minutes and then suddenly dropped back down. It looks like the vibration has stayed steady after this, so the problem was solved. Let's get some more information to be sure. First, I'll take a closer look at the spectrum. Here we have the vibration level history for the full spectrum. Let's go back to find the same event. Here it is. I'll zoom in for a closer look. I can use Smart Mouse again to check the exact time. This blue line indicates the vibration stopped briefly. That means the doctor was unloaded. I can see that the vibration dropped a few minutes before the Craping Doctor was unloaded. Maybe the operators have taken the sheet off with the cut-off doctor and then unloaded the Craping Doctor to change the blade. I can also see some disturbances at the start of the event affecting the whole frequency spectrum. The problem was triggered by a change on the machine. I should check the operator log to see if anything was mentioned. But first, let's check the blade change log to confirm that the Craping blade was changed when the doctor was unloaded. I click on the blade life monitor to bring up the log. The problem occurred around 5 AM on the 18th. The log doesn't show a blade change at that time. The same blade has lasted more than 24 hours after the event without any further problems. So the problem was nothing to do with the blade. The trend view has saved my position from before, so here is the event again. I can reset the view by clicking here. I'll scroll back to the event, and then I'll double the scope to see everything that has happened since. Vibrations have been steady ever since, and I can see over on the right 2 times when the blade holder was unloaded again. This first one is when the blade was changed. So what have I learned? A change was made on the machine that caused the vibration to increase. The operators have noticed the problem quickly and intervened and have successfully solved the problem. They broke the sheet and unloaded the craping doctor, but did not have to change the blade. If I want to know more, I should speak to the operators involved, since they have already solved the problem.
My thanks to my colleague James, who one of the developers of this system and recorded that demonstration for us. So the takeaways we have here, we've got a great dashboard, all the data, all the time. You'll notice we brought up a blade change log. We have integrated a blade change barcode scanner into the system so we can track every blade by its type and serial number. And finally, you have this excellent vibration FFT. We've used the powerful data park array feature to historize a very complex set of FFT full Fourier transform spectrum data. So troubleshooting, as James said, is made easy with this system. Here we've got a couple of FFT views looking very different. You can see immediately great visual representation where a dark red color is showing excessive vibration on the left-hand side with even after a blade change where the customer is reusing an old blade compared with much less dense color, and therefore lower vibration for a new blade on the other side here. The same thing in the spectrum view shows exactly what's happening. Particularly the top one, this is obviously on a German asset where we have the system installed. You can see on the trend view where vibration is on the vertical axis, much higher vibration across the bandpass frequencies we're monitoring of the old blade and the new blade. And that information is available instantly. In the old systems, you'd have to go in, download a history trend, and then analyze it. Laborious, and operators wouldn't do it. And customers incurred Yankee damage as a result of people not accessing the information quickly and easily. Having all of the data, all of the time, instantly available is a key benefit of this system, as indeed with any data powered system. So what else do we want to do? We want to integrate process data. That's a great idea. We can cross-reference vibration events with process events. But how do we keep that simple? The answer we came up with is this, the scorecard concept. We built different parts of process into unit op scorecards with an easy to read process scoring metric on them, using some custom algorithms to score parts of the process with an easy to remember number. Basically, if a process is scoring 100%, it's running perfectly. And we can combine these into a master dashboard. An operator looking at this master dashboard is only a few mouse clicks away from the system is pulling down the Yankee score, be it the steam system or maybe something in the chemistry system. So let's take a look. We use this to troubleshoot a process-driven vibration event. This is from a customer in Europe, a bad vibration event, which we want to avoid because this was a customer with a history of Yankee chatter damage. You can see the event clearly in the middle of the screen of the trend and on the FFT. When we dug into the data through the scorecard system, what we came up with was a corresponding process event. This was actually a rapid increase in the concentration or consistency of the white water, the water circulating around the tissue machine. And we trace this back to an unplanned addition of external broke into the system. Broke, for those outside the paper industry, is recycled scrap paper, in this case from the converting plant. Understanding this, the client changed their operating procedure for broke addition and documented savings of over $100,000 a month due to being able to use that fiber more effectively in a safe way, avoiding the potential of asset damage. So where do we go from there to wrap all of this up? We've built a good system. We have getting on for 30 of these systems now ordered and operating around the world. But what about Industry 4.0? Can this system take us there? But if we remind ourselves some of the things that are happening in Industry 4.0 systems, we're talking about smart sensors, we're talking about virtual sensors, automated process control, maybe in the future, AI controlling a tissue making machine. What have we got with Vigilance Pro? a data set which defines Yankee performance, the heart of the tissue machine, where the quality of the final tissue is determined by the creping process. Perhaps we could use part model to build a virtual sensor for quality. So we went ahead and did this. It's in a prototype stage now. We're testing this in 1 or 2 tissue mills around the world. This is the prototype dashboard softness control model built around Vigilance Pro, process data tags, and part model. So in summary then, we've come a long way since the original smart vibration alarm brief. Thanks to the Vigilance Pro powered by DataPark, we have the best-in-class tissue machine Yankee performance system, we think, globally. Moreover, we can leverage these DataPark capabilities into very powerful troubleshooting tools using the inherent capabilities of DataPark on our scorecard system. This gave us a big awareness of the future potential of this system as our capabilities grew. So we're now developing our virtual quality control platform, again with Vigilance Pro and DataPark at its heart. This platform is fully scalable and we expect more exciting developments in the future. Closing picture here is a picture of one of the early systems, Vigilance Pro Free, in action in a European tissue mill with Mark Corby here today on the virtual conference, and another one of the key developers of this system. So thank you today for your attention. I hope you found this presentation enjoyable and interesting, even if you're outside of the tissue industry. We'll alert you to some of the possibilities of DataPark and custom dashboards and custom data inputs. And I think at this stage, we now open it up for more questions. Thank you very much.
Is Ian joining us? There we go.
Yep, here I am.
Hi, Ian.
Hello there. Hi, Molly.
Thank you so much for your presentation and sharing a practical application of DataPark. It was nice to see those different types of dashboards. And thanks again for joining us all the way from the UK. What time is it there?
Oh, it's 7:30 in the evening. Beautiful autumn evening here in the south of Scotland.
Well, thanks for working late for us.
No worries.
We did get a couple questions come in. So on that first example, does that require sensors to be installed on the doctor blade holders?
Yes, exactly. We're using a fairly standard accelerometer, similar to what you'd use for condition monitoring the rotating elements, bearings, gearboxes, so on and so forth. We spent quite a bit of time getting the frequency response right on those, using that same vendor's data loggers, and then we interface to the data logger with the Vigilance Pro system.
Great. And then for the scoring system, how did you come up with the scoring system or algorithm? And is it custom for each site, or is it did you standardize it across all the sites?
That's a great question. On the customization and standardization, the answer is yes and no. It works like this. We started out by identifying maybe, I think there's about 24 key performance indicators you can track around a Yankee coating system and the Yankee dryer, particularly the steam and condensate system, which will indicate if you're running well or likely to be in a vibration condition. We first take the process data and we compare it to what would be industry best practice for something where an industry best practice is really well defined. So something like the pH of the white water of the paper machine, generally speaking, best practice says between pH 7 and pH 7.5. So if you're in that range, you're getting a high score, 100%, and then you go outside that range, above or below, the score drops off and pulls your score down. Other things would be, say, the Yankee coating, which tissue makers there will know we generally talk about milligrams per square meter of polymer coating sprayed on a Yankee. That's going to be site specific. So we would work with the customer's process engineers, quite often doing our own bump testing around the system during the commissioning stage, and we would define what is good for that machine, which is, what is specific for that site, which is good for them, and then deviation from what works best on that machine, in that case, would then be coded in. And there's a little, for those familiar with DataPark, it's a typical MDE field where we can code in what the, if you like, best practice or perfect score value is going to be, and then we take it from there. So the system is quite flexible. There's a standard set of parameters coming in. Some of these are a standard best practice top score. Others are customized according to site conditions. I hope that answers the question specifically.
Yeah, I think so. So another question came in, and I think it might just be a general question on the site, but do the sites you're working with have sub-second data?
Sub-second data? Generally, yes. I mean, we would be doing this through a data park interface, and generally we're getting data sub-second or at about the 1 second frequency for that. Yeah. I think there may be some specificity according to exactly what kind of OPC server we're interfacing with and what data is presented to that, but generally speaking, we'd go for sub-second data.
Cool. And we have a couple other questions. So do you think that you could create a scoreboard based on a system that is not constant? For example, deviation from a golden run that represents a perfect batch run?
I think that could be done. We've talked about making some of the features in this kind of grade specific and things like that and enlarging it a bit. We start to layer on some complexity there. That's certainly an idea that we've been discussing. I think there's probably a few other people on this call taking notes now who'll be able to answer that really well. I've referred to Mark Corby. If Mark's here, that'd be a great question for him to take and bounce back to the respondents a little bit later on.
Do you use the center lining tool at all?
Yep, we do use that. We use it all the time because we do more data park than just this. But we can be using that to look at some of these process parameters and then going back to the golden run concept, trying to define what is good for that site would be a good thing. Moving forward, we were then incorporating, because the data can flow both ways. If this can be a standalone system where a customer doesn't have data park, and it will just interface to a DCS or third-party historian, or sometimes even just a PLC, and we can run it like that. So there's not a great deal of data park visible there other than what you see. In other systems where a full data park suite is installed and this, then we can send data the other way and incorporate a lot of this vibration and Yankee performance data into the centerline tools that the paper makers and process engineers are using in other parts of their process. And that seems to be a really rich area for the process engineer to start mining data about their process.
And I think we have one last question here, again on the scoreboard. Is the scoreboard using any grade-based limits or rules?
As I said earlier, we've not quite done that yet. That's a development that we're planning to bring in.
Great.
It's a very obvious step to take. We've made the system, the base Vigilance Pro system, grade aware, as long as we're getting the right tag. So we've got some quite good functions where we can search by grade and search by blade type. To then migrate that to the scorecard system, that's definitely something, an area that we want to get to next.
Great. Well, I think that wraps up our questions. Thank you so much for joining us for this live Q&A and answering the questions.
Well, they were great questions. I thank you. There's some smart people out there in the audience, so thank you for listening. I hope you enjoyed it.
Great. Thanks, Ian. Okay, well, that wraps up our conference for today. Thank you, everyone, for your questions and participation. The more you ask, the more everyone gets to learn, so we really appreciate that. We also appreciate your patience working through our first virtual conference. Since the product development presentation was cut a little bit short, we've decided to pull back Kevin and Steve tomorrow. So tomorrow they will come at the end of the day and field some more questions. We have those questions from that we didn't get to during their presentation, so we'll answer those questions end of the day tomorrow. We hope you'll join us again tomorrow with our new host, Data Parks Project Manager, Jacob Jakubik. He'll lead us through another round of great presentations starting at 8 a.m. Pacific time. Thank you for joining us, and see you tomorrow.